Hello, everybody, and welcome to If Oxford and Glow Your Own 2024. This is the fifth time we've done Glow Your Own, and it's great to see some returners and loads of new people who are going to be learning coding across this 6-week course. My name's Dane, I'm the festival director, and it's great that we are joined again by Sophie and Sarah. So how about we introduce Sarah first?
Hi everybody, I'm Sarah. I work for Science Oxford. We've got a little science centre up on the outskirts of Oxford in Headington, and I usually run coding clubs in person. So I'm really excited to be here doing this online event again this year and seeing all the cool things that you create over the next few weeks. Welcome everybody.
Thank you.
Awesome. Hello everybody. It is wonderful to see you all here. I'm Sophie, and I'm very much looking forward to Glow Your Own. I work this place you can see behind me. I'm not actually floating in space, it's just a picture. So I work at the Rutherford Appleton laboratory, which is just outside Oxford. So you might have seen, if you've been traveling on the A34, strange shiny donut shaped building. That's where I work. We do loads and loads of amazing, really, really exciting science. And one of my favorite things that we do there is lots of coding to make all of the science work and to understand all of the science that we do. And we do it in ways that nobody in the world has ever done before. So I really love how creative it can be. And I'm really excited to be able to do some lovely creative coding with all of you.
Yeah, great. Thank you. So I think just to whet your appetite, so we've got some coding that we're going to be doing, but just to show you very quickly the kind of thing. So it looks very complicated. So I've got an egg box full of Arduino bits and pieces here. It looks really complicated, all these wires and bits of stuff. There you go. You can see the Arduino here. There's the breadboard, there's some LEDs, there's some wires, and I've numbered the wires and the LEDs to help, because if I close my egg box and I turn on my power supply, it will do this. So it's really simple, but you can make this sort of thing just yourself using all of this kit and the coding that you're going to be learning over the next few weeks. Okay, so I'm going to disconnect that because it's really bright. And I'm going to pass on to Sophie to get on with some coding. So
Absolutely.
Sophie's put the Tinkercad code that you can join already in the chat. And you have hopefully been given your Tinkercad code in the email. It's brilliant if you can log into that, because if you need help later on, it means that we can see the working that you've been doing ahead of time, so we can help you later on in the troubleshooting. So the way this is going to work is we have an hour's lesson, if you like, that's recorded, and then we have the half an hour troubleshooting bit at the end, which is not recorded. So you can stay behind, turn cameras on, and we'll give you some help. And so you can watch the recording on demand if you're not able to come along to one of the sessions, or if you just want to watch it again. But we don't the last half an hour troubleshooting help session. So if you want to join the troubleshooting help session and you're watching this on demand, you need to come to the session and we'll be able to help you if you get stuck, and we'll be able to help you with any of the problems that you've been having with your Arduino and your coding. Okay, that's enough from me. Are we ready to crack on?
I think so. All right, thank you, Dane. Let's get started. So I'm just going to share my screen quickly. All right, can everybody see a screen that says Tinkercad? Thumbs up from Dane. That's good. So you should have seen the link for this in your chat. And then when you click on that link, you should get to this page. We're going to use Tinkercad to do all of our coding and all of our circuit design. It's really fantastic. Really fantastic website that we can all use. Once you get to this point, then we're all going to join with a nickname. So that's the name that Dane just mentioned that you should have received in your email. So once you've put your nickname in, you should see a lovely screen like this. So like I said, Tinkercad actually does lots more than we're going to be doing with it over the course of Glow Your Own. And I really encourage you to go and have a play with all of the amazing things that we can that you can do with Tinkercad. You could do 3D designs, you could do all kinds of other things. But what we're going to do is create a circuit. So I'm just going to pop the link to the Tinkercad classroom at the bottom of the chat in there again, just so it's nice and easy for everybody to get them. Like that. Okay. So I can see that Dane and Sarah are checking everybody that doesn't have their nicknames and are getting through them as quickly as they can. All right. So once you're here, we are going to click this and say create your first circuits design, because we're going to make a circuit. We're going to make a whole bunch of lights light up today. That's our task. So once you're in, you can click on this button that says create your first circuits design, and then we get there. Brilliant. And this has got loads of really great things that we can do here. All right. If you don't have your nickname, please do put in a chat that's just to Dane or to Sarah what your surname is, because that will make it easier for them to look up what your nickname is. All right. So this is where we're going to design our circuits and where we're going to code our circuits. So where we're going to tell our computers what we want them to do. Now, the first thing that I always like to do when I start a new circuit is to give it a name that I'm going to remember what I was doing, in it. And you can change the name of your Tinkercad circuit up here in the corner on the right, left. Sorry, I'm not very good at left and right. Dane teases me a bit about it, but that's okay, because I know that he's just laughing with me. So I'm very sorry if I say left or right, and I mean the other one. So up here on the left, you can change the name of your circuit. So I would always call it something that you're going to remember that's going to be quite obvious what it is. So for this one, I'm going to call it GYO1 because it's the first session of Glow Your Own. And then I'm going to put light, because what we're going to do is we're going to turn a light on. That's how we're going to, that's our task for today. Sorry, I'm just going to sneeze. No, I'm not. Now, there are lots of ways that we can turn a light on with our light switches, for instance, but we want to turn lights on in pretty patterns. We want to eventually we'll turn lights on when we press buttons or all kinds of things. And to do that, we are going to use something called an Arduino, which looks a bit like this. Now, some of you may have heard of Arduinos before. They're really, really useful things. And what they do is they're just a small thing that you can use to control other things. So it's looks a bit complicated, doesn't it? But it's actually got lots of things that are pretty much the same. We just want to be able to do lots of things at once. So this is our Arduino, and you will get your actual Arduinos through the post before we need to start making a real one. But it does all kinds of clever things. We can connect different components, things like lights, to our Arduino and buttons and stuff like that. And we can use the Arduino to send instructions out to those lights or to get information. So we could use an Arduino to measure the temperature around us, for instance. And it can send information out through all of these, what we call little pins here. You can see they're all numbered. And you can also use it to get information back in. And as we go, we'll learn about different pins because they all do, you can use them to do different things. Okay, so just to show you a bit around Arduino, around Tinkercad rather, over here on the right-hand side, we've got all of the different components that we can use. So we can make a circuit in our on our computer that uses any of these different components. And some of them you will know what they are. Push button, that's fairly obvious. It's a button and you push it. But some of them are a bit more complicated, perhaps. And what you can do, you can see up here at the top, there's this button that says Components Basic. If you change that, you can see all kinds of different ones. And you can see more. Sometimes it says basic, so you can change the number of ones that you see. And if you press this little button here, it says switch to detail view. Then it gives you a little explanation of what all of the different components, the different bits that you can use are. So it will tell you exactly what it does. So push button, a switch that closes a circuit when it's pressed. All right, so I'm just going to pause there for a minute, because what I want you all to do is to find the Arduino on your circuit. So here it says here, Arduino Uno R3. That's just the type of Arduino. Click on it, and then you just drag it over here into the main space where we're going to be making our circuits. All right, and when you've done that, you don't need to. I'm going to delete one of them, which you can do by pressing this delete button up here. Once you've got your Arduino out here, just put a hands up, or you can do a reaction. So there are lots of cool reactions. I can't remember what any of them are now. Hands up, thumbs up, ticks. Brilliant. I think you can do parties. Great. We've got a lot of people that have got that sorted. Fantastic. Oh, got a little celebration one. That is a nice one. Fab. So once you've got it, you can move it around just by clicking on it and then moving your mouse around the screen. All right. So I think quite a lot of us are there now, which is fantastic. So we're going to get the next step ready. Now, I know that not quite all of you are there, but don't worry, we are recording this, so you can always watch the recording, and then you can pause us at each step so that you're completely up to speed with all of the things. All right, so the next thing we want to do is a thing with a bit of a weird name. We want a breadboard, and it's not a kind of breadboard that you use for chopping bread. It's a breadboard is something that we use to help to create circuits for the first time. So you can see it here. It's called breadboard, small. So you click on it and then pull it over here to the right. No, to the left. I'm going to have put stickers on my computer to tell which side is left and right. And this will help us to make our circuit, because the problem with making circuits in real life is you've kind of got to connect all of the wires together, and that can be a bit fiddly, and especially if you think, oh, I want to put a wire here, and then actually it turns out you want to put a wire in a completely other place. You've got to redo it. What these can do is there are connections built into these breadboards, and so you can use it to connect up different things, so different lights, different buttons, different wires, and then you can move them around easily. And Tinkercad is really helpful because it shows you what all of those connections are. So if I take my mouse and I hover over one of these little holes, which we call pins, you can see that they are circled, that there are a whole bunch of them that are circled in green. If I zoom in a bit, you might be able to see it even more clearly. So if I put there, you can see there are 4 ones that are circled in green. If I move over here to this one, it says, right, you're clicking on the one with the red square, but it's connected to all of the ones that are circled in green. So if I put a component here, it would be connected to anything else that was on that was circled in green. And if I go down to the bottom, they've got really long ones with loads and loads of connections, which can be really helpful. One there and one there. So what we're going to do is we are going to make a light turn on. So once you've got your Arduino and your breadboard, we are going to get an LED. Now that stands for a light emitting diode, which is a fancy way of saying a light. So you can go over here to the LED. For any of these components, all you need to do to get them is click on it and then just drag it over to where you want it to go. And I'm going to drag it over here and then just let it go. So now it is connected. It's connected into my breadboard. You know what? I think last time somebody told us why it was called a breadboard, but I can't remember what the reason was. And it looks like from Dane's face, Dane can't remember either. So maybe that can be everybody's secret task for the rest of the week. We can look up, we can all see if we can figure out why it's called a breadboard or come up with a fun reason. All right, I'm just pausing for a minute so everybody can catch up. So we've got 3 components and we've got 3 more to go. So we are halfway through already building our circuit. And what we want to do next is we're going to connect our Arduino to our light. Okay. We're going to do that with a wire. And wires are really easy in Tinkercad because all you need to do is click on where you want the wire to start. So click, I want it to start on D7, then you can see it actually goes a bit glittery. If I zoom in a bit, you'll see it even better. Oh, goes all glittery. And then move to wherever you want the wire to end up. So you can see I can move it over here or over here, but I want to connect it so that it connects to my LED. So I can put it up there and then you can see my circuit will go from the Arduino all the way through the wire, through the breadboard, and then to the LED. The next step that we want to do is use another component, a type of component called a resistor. And what a resistor does is it just reduces, in fact, let's have a look, shall we, what a resistor does. If we click on this, Tinkercad will tell us. So a resistor restricts the flow of electricity in a circuit. So the Arduino is going to send electricity through to my LED, but it's just a little LED and it doesn't actually need that much electricity in order to work. So we're going to use a resistor to reduce the amount of electricity in the circuit, and that will make it glow at the right kind of level. And then what we're going to do with our resistor is we're going to take it and we're going to move it so that it goes from the other leg, the other side of my LED, to this green line here. Okay, so now if we trace our circuit or our path that our electricity is going to flow in, it goes from here, from our Arduino, we go along the green wire, up through the breadboard, through the LED, back down through the resistor, and then here it is ending up here. So we've only got one more component to do, one more wire. But before we do that, I'm just going to change something about my resistor. So you can see if you click on the resistor, it comes up with this little blue box. And I could give my resistor a name. So I think I might call it resistor Reginald, because Reginald's a nice name. So you can name it just to help you do what you're doing. But then there's this thing called resistance, and that's how powerful your resistor is, how much it's going to restrict your electricity. And that is something called 1 kiloohm. And an ohm is just like meters or miles. It's just a measurement, a unit of how much it resists it. And that's a bit much. I don't want too much electricity going to my LED, but I want a bit more than that. So I'm going to change this. Instead of 1 kiloohm, I'm going to change this to an ohm. That goes there. Oh, and there we go. And I'm just going to change that to 220. You can do that. You can also change the color of your light if you want, and give your light a name. So LED. So we could call it LED Laura. Good name. And I could change it from a red LED to a green LED, say, or yellow one. But I quite like red, so I'm going to stick with red for mine. One more wire left to go, everyone. Just to finish this circuit, to complete this circuit, and that's always really important, because otherwise the electricity will go up here, along here, through the LED, and then it'll just like, oh no, I don't know what to do now. I can't get anywhere from here. So we're going to go back from our breadboard all the way back down to our Arduino to the pin that is labeled GND. So I clicked on the same row that my resistor was in, and then I brought my wire back down to the GND. And GND stands for ground. And that is the word that we use for the negative, or just to the end of the circuit, at the ground of it. And now you can see you can do a complete pass all the way around my circuit. So it goes from the Arduino through the wire, through the light, through the resistor, through the breadboard, back down to the wire to the GND pin. And now we've done a whole circuit, which is amazing for only half an hour of working. Fantastic. Let me know when you are ready, because our next step is my favorite bit. I like the circuits, but my favorite bit is the next bit, where we're going to give our circuit instructions. My brother says I'm very bossy, so I like telling things what to do, and that's what coding is, telling the computer what to do. Oh, we've got lots of people who are done. Fantastic. The resistor, just to repeat, is meant to be 220 ohms. So that's like 220 meters, but instead of meters, it's the unit, it's the way we measure resistance. And that's called ohms. I don't know why it's called ohms either. Maybe it's after Mr. Ohm. Oh, we've already had one great bit of science history. Maybe we'll get another one by the end. Fab. Right, we've got lots of people who are ready. You're amazing. Now we're going to do my favorite bit, and we are going to code our computer. We're going to write a set of instructions for it. So you can see up here at the top, there is a button called code. So you click on that, and then it comes up with this thing, which for those of you who have done it, looks a lot like Scratch. Okay, so use this to give it instructions. Now, whenever you start Tinkercad 1, it gives you some, oh, would you like to give it this instructions? No, I wouldn't like to give it these instructions. So we're going to delete these instructions, which you can either do by clicking on it and pulling it down here to the little bin at the bottom. It makes a nice little whoosh noise. Or you can pull it over here to the side, and then it does the same thing. All right, so just to start our code, we are going to, what we want to do is we want to send an instruction to our light to turn on. Now you can see the light, the LED, is connected to the pin that's called pin number 7. Yeah? So what we want to do is we want to send an instruction to pin number 7 that says high or on. Sometimes we use high instead of on. And you can see in this output, which means sending out an instruction, there is an instruction that says set pin to high. So what we're going to do is we're going to grab that one and pull it out into our coding area, which is just like we do on Scratch. But we don't want to send an instruction to pin 0, do we? Because there's nothing in pin 0, so the Arduino wouldn't do anything. You can change that pin to pin number 7. All right, So now we've got this instruction, set pin 7 to high, send an instruction to say turn on. But we just need to tell the Arduino how often we want it to do that, when we want it to do that. And we can find that in this part of the coding, which is called control. So if you click on this little orange bit, you've got all kinds of different instructions that are all about control when we tell the Arduino to do things or if we're asking it questions. And to start with, we just want oh, sorry, I clicked off. We just want our Arduino to turn our light on forever. We always want that light to be on. So there's hopefully a little command called forever. And so I'm going to put that there. And you can see that if I hover it over it, that set pin, that instruction is inside my forever loop. That's what we call them. We call them loops, forever loops or forever blocks. And so that means that forever, the Arduino is going to be sending that instruction. Okay. So for those of you who have done some Scratch before and maybe want to use some so a different type of coding, you can actually change from using these nice blocks where we can just pull them out to using text-based languages or blocks plus text. So you can write your instructions in 2 different languages. So it's like saying please sit down or asseyez-vous. You can say the same thing in English or French, same instruction, just a different language. So if up here, you could change this to blocks plus text or just blocks or just text. And you can write in this Scratch language or write in a language called C++ code. Again, can't remember why it's called C++, but there is also a C. But we're going to use the blocks just because it's easy to do that. All right. And then we are going to start our simulation. So one of the things that is great about Tinkercad is it means that you can test out your circuits before building them in real life. So you can test if your circuit design is right, you can test if the instructions are right. And by doing this thing called start simulation. Now I'm going to zoom out a little bit so you can see. Come back. Okay, so you can see all of my circuit and all of my code. Then up here, there is this button called Start Simulation. All right, and when we press that, if we've got the code right and if we've got our circuit right, then our LED should turn on. So fingers crossed. Give me a thumbs up if you are ready to start and to test out your code. Fantastic. Lots of thumbs up. Oh, and a bread. That's marvelous. Just like the breadboard. Fantastic. All right, then. Let's all test it together then. I'll count down from 3 and we can all press start simulation at the same time and we'll see if it works. All right, if it doesn't work, don't worry because we've got the kind of help session at the end, the debugging session at the end, and you can always rewatch this on the video and pause to make sure that you're up to speed. So let's get started. All right, so 3 on 2, 1, start simulation. And you can see that my LED has turned on. You can see it's a beautiful bright on. So my circuit worked and my instructions were right, which is fantastic. Give me a thumbs up if your LED also turned on. You can start it and stop it. Yeah. Fantastic. Well done. Good job, everybody. That's amazing. Brilliant. So you have all made that first step of getting the Arduino to send an instruction out to a real thing that we can then use to control and make some amazing art. Maybe we'll make some Christmas lanterns. My friend Vicky, who works with me, who's gonna join us for some of these sessions, She really wants to make some constellations with lights that flash on and off. And actually, Dane already showed you the beautiful circle. But if you look behind Dane, you might have noticed a very beautiful artistic lamp that's been gently changing color as we've been talking. And that was Dane's project. Was it from last year, Dane? Oh, he's muted, so he doesn't know. So Dane's just going to show it, and then we'll do another couple of coding things before we wrap up for today. Was that from last year, Dane?
This is from last year. Yeah, we did a little tetrahedron, which is a triangular-based pyramid, and I had it coding in different colours, and it just did this, which is quite fun. So there's all sorts of fun things that you can do with these LED kits, and they're very similar to the kind of devices that Sophie's colleagues make. So you might be familiar with the James Webb Space Telescope, and people at STFC RAL made parts of that, and all sorts of other fancy experiments where motors and sensors are used in real science. And so what we're doing is doing a really simple version of some of that, and just because it's fun and the clocks are going to change at some point soon, and so it's just nice to have something that's pretty and colourful and flashes or just glows up nice and slowly. So that's the idea, is you can make something good. And it all starts with this single LED, which you've just coded up, or many of you just coded up, which is smashing.
Right, I think we've got time. We weren't actually planning to go this far, but you've all done so brilliantly that I think we can do a little bit at the next step, and we will. You can see that Dane's lamp is flashing on and off, so we will make our little LED flash on and off as well in a pattern or however you feel like it. And so to make our LED flash on and off, we basically just have to send a series of instructions to the LED saying turn on, turn off, turn on, turn off. And we can do that in lots of different patterns and lots of different ways. And we could add more LEDs as well if you wanted, just like Dane has with his lamp, and connect them to different pins so we can send different instructions at different times. But for now, let's just make our light flash. So we've got that first step. We send an instruction that says set the pin to high. Oh, some people are already on it. You're amazing. And then what we want it to do is we want it to stay and wait for a bit. We want it to remain on for a second. So you'll see here in my control group, I've got this instruction that says wait for 1 second. So I'm going to put this out and click that in so that it says wait 1 second. Now I could change that to wait 2 seconds or half a second. Could even change that to milliseconds. So pop in the chat how many milliseconds are in 1 second. But it's a shorter second. It's a shorter period of time. You can pop in the chat how many milliseconds you think are in 1 second. It is indeed 1,000 milliseconds in every single second. But that's pretty quick that's a bit too quick for me. So I'm going to say just wait for half a second, and then I want to send an instruction that says turn off. So I'm going to go back to output, because you remember that's where we found sending out instructions. And I'm going to set this pin again. I'm going to put that after. So after it's waited, we're going to send another instruction out to the pin. So I've changed the number, so it's sending it to pin 7. But this would say set pin 7 to high. And so that says turn on again, so it wouldn't flash off. What we want to do is change this high to low. So we've got 2 instructions, 2 different instructions now. So set pin 7 to high, turn on, wait, then set pin 7 to low. And then, and this last step is important, we want to add one more command that says wait again. So wait half a second. You can pick whatever number in there you want. and it will follow it out. So now we're going to set the pin to high, turn our light on. We're going to wait, going to set it to low. We're going to wait, and we're going to do it, and we're going to do that forever and ever and ever and ever. Now you can see you could make all kinds of different patterns. You could use Morse code to flash. You could write it to flash a message if you wanted. So you could have long ones and short ones. You could do all kinds of things, but I'm just going to make a pretty pattern for now. So I've made my instructions. I'm going to test it to see if it works. So we're going to start the simulation. Think about it. Oh no, sorry, it seems like my code has some errors. I don't know what that error is. So let's try again. I think it was just getting a bit confused, or maybe I hadn't deleted something. So now I can start my simulation, and you'll see that my light is flashing on and off, and people's are working. That's fantastic. Good job. Give me a thumbs up or something if you've got it to work and to flash in a beautiful pattern. And see what other patterns you could use to make it flash. Now we use something very, very like this, like Dane said, at the lab. In fact, almost exactly like this. So a lot of our labs have very sensitive equipment in them, and we need to make sure that they stay at the right temperature, or the right light level, or the right level of humidity, the level of water in the air. And so we have some Arduinos, and they are hooked up to some temperature sensors. And if it gets too hot, or if it gets too cold, then a light flashes on and off, and on and off, and on and off. And so that's almost exactly the same thing as we have done today. In another few weeks, we will be getting it so that it reacts to the light, or to a button pressing. Now, don't worry if yours isn't quite working yet. It's probably something really, really simple. So one thing that I do all the time, so you can see this wire. One thing that I do is I get a bit lazy about where it goes. So instead of being connected to my resistor, to the same line as my resistor, I do it. Oh, sorry, I just need to stop the simulation or it won't change. Then you can stop the simulation. Oh, it really doesn't want to stop. It was like, I'm having too much fun.
Taking over.
Yep, I do that. And so if your circuit doesn't quite go all the way around, you can see there's nowhere for the electricity to go. So nothing would happen. If your light is turning on, but it's just not quite as bright as mine is, probably what it is that this resistor is a bit too powerful. And if it's a bit too powerful, that will stop the amount of current, of electricity that your LED gets, and so it won't be as bright. So you can change that by clicking on it. Then you can see that my resistor information comes up. So you can see resistor Reginald. I've spelled resistor wrong, which is not great, given that it's just there, but anyway, there we go. And that should be 220. And then make sure this is just this ohm signal, this ohm sign, this funny little circly thing, and not K ohm, kilo ohm. That would be 1,000 ohms, so it'd be much, much stronger. So hopefully, and I know a lot of you have got that working, which is fantastic. Well done, everybody. But if it's not quite working, don't worry, because we can always fix it in the debugging session, and we can always, you can always watch the recording and just make sure that everything is exactly the same as it is here. And so the code is getting the right instructions. So we've got some wonderful work and it's brighter now. That is fantastic. Good job, everybody.
Oh, hey, Sophie.
Yes, Dane.
One thing that people might enjoy doing is that you can change the color of your LED. So you've got it red at the moment.
So you're right, I can change the color here. So I like a red LED. But if I changed it to yellow, then I could do that as well. Flashing, flashing, flashing. We've got some lovely LEDs.
They're already great.
That's amazing. One of my favorite circuits to do is to make a rainbow. So to have lots of different LEDs in all the different colors and make them flash one after the other, red, orange, yellow, green. It gets a bit complicated when it's blue, indigo, violet, because we don't have indigo and violet LEDs, but you can combine the colors to make them look like we want. So we've got just another couple of minutes. So what I'm going to do is I'm going to add in two more to make a bit more of a pattern to my flashes. So I'm going to wait again. I'm going to send another instruction that says turn on again to pin 7. And then I'm going to get it to wait. But instead of waiting for half a second, I'm going to get it to wait for 1 second. And then I'm going to do another one that says turn off. We're doing this a bit quickly for the first session because we don't have lots of time left. And then wait again. So now it should go flash, flash. It should go flash, 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 flash. So the length of time that the LED is on should be different because I've told it to wait a different amount of time before sending that instruction out to the LED. But let's see if it's going to work. Okay. And like I said, I did do that pretty quickly, but that is because we're right at the end of the session. And you can always watch the recording. So 3, 2, 1, let's start the simulation. So you can see that we've got a short flash and then a long flash and then a short flash and then a long flash and a short flash and a long flash. So you can see you could make all kinds of different instructions that send it out. And we do very similar things. So Dane mentioned the James Webb Space Telescope, which is an amazing telescope. It launched nearly 3 years ago on Christmas Day, and is taking amazing pictures of the universe as we speak. And it's sending the information back to Earth, all of those amazing pictures and that amazing data that we're collecting and learning about the universe. It's sending it back basically by sending flashes of light back to us to so that we can see what it's seeing. It's pretty cool. If you get a few minutes, always just go and have a look at what the James Webb Space Telescope is looking at, because it's always amazing. Brilliant. Well, we are, I think, pretty much at the end of the thing. So I'm going to stop my share and say a huge well done to everybody. See all of the different things that, so you can experiment with all of the different things. This session was very much that introduction, so we could get everybody started. Next time, we're going to start with making the circuits in real life and doing a bit more, adding in some other bits and other components so we can start to make our LED react to the world around it. But it all starts from that very simple turning a light on, which is where all of these things, all of the experiments that go on behind me, that's pretty much how they all start. Well done, everybody. I'm going to hand back to Dane now.
Great. Yeah, well done, everyone. That's brilliant. And Sophie, I did like your flashing, and you were writing in Morse code ET.
Oh.
So a dot and a dash. So the dot is E and a dash is T. So maybe you were sending a message about
Totally, I know
looking
Morse
for
code.
extraterrestrials. But yeah, really good work, everybody. Some great thumbs up saying to us that you've done some good work. But if there are any problems that you've been having, please stay behind, and we'll be able to give you a bit of help in the troubleshooting session. But great to see everyone doing some really good coding and getting started, getting familiar with this new thing called Tinkercad, and getting familiar with your breadboard and your Arduino. And we'll then start building the physical thing next time. And please do register your interest in seeing if we can send out an Arduino to you. We do have a small amount of money that will be able to cover this for people that need it. But we do ask, if you can afford to buy your own, please buy your own, because it means that we'll be able to help people that find it difficult to buy their own Arduino. Okay, right. So we're going to sign off for now. So well done, everyone, for doing some great coding. And thanks for Sarah for helping in the background, and for Sophie for leading a great session, and for loads of you from across the country, from Milton Keynes, London, Liverpool, Bicester, Oxford, and all over the place, getting to do some coding today. And we will see you next week. Bye, everybody.